Good evening, everybody. Tonight we're going to be talking about rotations again. Yep, one more night. But tonight we're talking about rotating around any single point on the coordinate plane. So come along with me tonight and we're going to check out how we can do this. But first, let's check out our objective. By the end of tonight, we're hoping that you can draw the rotation of a given figure on a coordinate plane and determine the properties preserved, which means you're going to be able to describe what is kept the same about those figures. So let's see how to do this. Let's take a look. It says triangle A prime, B prime, C prime is a 180-degree rotation of triangle ABC about point A. What is different about that statement? Well, usually we've been rotating all of our figures about the origin, but not tonight. Tonight we're going to be rotating about point A, which means this figure will turn 180 degrees or in the complete opposite direction around this point here, which is A, instead of the origin. So let's take a look at how this figure will actually move 180 degrees about point A. If you look at the corresponding sides, AB and A prime to B prime, they make a 180-degree angle. Well, let me erase what I have here, and let's take a look at what that means. If I look at A to B, and then I look at A to B prime, notice first of all the lengths of these lines from our vertex A to B and from our vertex A to B prime are the same distance. Also notice that if I put these together and I actually connect them all, it creates a straight line. And we know a straight line that goes through vertex A will create a 180-degree angle. That's why this is called a 180-degree rotation of triangle ABC about point A, because that 180-degree angle is formed around the vertex A. Notice, though, how my points are moved. So let me erase this so you can see it a little bit better. And let's take a look at specific points. Vertex B, if we were going to start here and look at vertex B, and we go from our vertex A, which is where we're starting this rotation, to get to point B, I am going to move 2 units to the right and then 3 units up. So 2 units to the right and 3 units up. But it's completely opposite, which is a 180-degree rotation, if I'm going from vertex A to B prime. So instead of 2 units to the right, I'm actually moving 2 units to the left. Then I'm going the complete opposite direction again, and I'm moving instead of 3 units up to B, I'm moving 3 units down to B prime. So notice they are in the complete opposite direction, which is what a 180-degree rotation is. Only this time that 180-degree angle is formed about our vertex A, and that's the difference. We are now rotating around a point that is not the origin. Let's take a look at this triangle. Triangle ABC has vertices A, which is -2, 0, B, 0, 3, and C, 0, -3. We want to rotate triangle ABC 90 degrees clockwise about the vertex A. So once again, my rotation is not going to be about the origin, it's going to be about vertex A. So let's take a look at how that rotation is going to take place. First of all, if I were to circle vertex A, that's the point that this whole triangle is going to rotate around. Now it's going to rotate 90 degrees clockwise. Think about the direction of a clock. That means it's going to be rotating to the right because that's a clockwise rotation. So let's see how that is done. If I were to look at my vertex A and draw my line connecting it to point B, notice when I take vertex A and connect it then to B prime, those distances are again the same. It's the same length from vertex A to B and from vertex A to B prime. Notice also what is created. Here it is, my 90-degree angle. And notice my angle opened up and turned B from where it's located to the right to B prime, which is the 90 degrees clockwise rotation. So remember, when we're going clockwise, my figure is going to move to the right. I'm still going to create that 90-degree angle, only now it's going to be around a different point. And in this case, it's around vertex A. But let's check how our points or our coordinates come into play. Let me erase that to make it a little bit easier for you. If you look at moving from vertex A to point B, notice I'm moving to the right 2 units. So I'm moving to the right 2 units. Then notice I'm moving up 3 units. So first I'm moving to the right 2 units, then I'm moving up 3 units. Now remember, when I've always done 90-degree clockwise rotations, the first thing I always did was I reversed my coordinates, or I put XY becoming YX. Well, guess what's going to happen when I actually do my movements about any vertex? I'm actually going to change my directions to the opposite as well. So how do I get then to B prime? Well, first thing, if I reverse them, instead of going to the right 2, I would now be going to the right 3, because look, I'm reversing my 2 directions. 1, 2, 3 units to the right will make it even with B prime. Now to move down to B prime, I'm going to go down 2 units. So instead of up, I'm going down 2 units. So that's how I will move my point from B to B prime. I start at my vertex A, and notice I went 2 to the right, then 3 up. So I'm going to do the opposite to get to B prime. I'm now going to go 3 to the right and 2 down. Let me erase that to make it a little bit easier for you to see. There we go. Hopefully you wrote that information down. So the corresponding sides, AB and A prime B prime, make that 90-degree angle, which is what we talked about. Here it is again, from here to here, we're making that 90-degree angle. Notice that the vertex B is 2 units to the right and 3 units above vertex A. Vertex B prime is 3 units to the right and 2 units below vertex A. Try to remember that when you're making your rotations around any point. Now let's draw the image of the figure after a 90-degree counterclockwise rotation about point T. Well, over here you'll notice here's point T. So this is what we're actually rotating around. We're going to label the coordinates of each point on the new figure. So let's start with R. If we look at point R, actually let's start with U. I'd rather start with U. If not you personally, but the letter U. Haha. So let's look at point U, which is right down here. Its coordinates are 11, 11. So I'm going to go ahead and write those in. Now I want to rotate this 90 degrees counterclockwise. Counterclockwise means I'm moving it to the left. That's what counterclockwise means. So this whole shape is going to be moving this direction, or to the left. Now I need to make a 90-degree angle with my vertex, which is T. So if I take U and I draw my line to T, here's my original, I know I need to make a 90-degree angle with vertex T. And that's what I just drew in, that 90-degree angle. So because it's 2 units below T and the original figure, when I create my 90-degree angle here, it's going to be located here. So this will be U prime. So now I have my counterclockwise because it moved to the left, and it's now creating that 90-degree angle with vertex T. So my new coordinate will be 13, 13. So I'm going to go ahead and write that in. Now let's take a look at T. Does T ever change when I'm making my rotation? Well, if I'm rotating T to the left and I'm about that point, it's going to stay the same. So because it was 11, 13 to start, it's going to end up at 11, 13 since I'm rotating around that point. Now let's take a look at S. S is located over here. I know I need to go in the direction of the counterclockwise, which is I'm going to the right. I hope I didn't say left before. I think I did. I'm moving it to the right, or counterclockwise. So let's take a look at how I'm going to do that. If I were to count how many units, 1, 2, 3, 4, 5, 6, 7, 8, 9, it takes 9 units to move from T to S. That 9 needs to stay the same because we know it's a rigid motion. So if I start at T and I know I moved S to the right, I'm going ahead and writing 9 units down. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here it is. Point S prime. Notice that if I were going to draw this line from T to S prime and draw the line from T to S, it's the same length and it creates a 90-degree angle with vertex T. So I know I'm moving that in the right direction. Now let's go ahead and move point R. Remember, we're going counterclockwise, so we're going to the right. I'm moving that shape to the right. So I can easily put R prime here because I know that R is 2 units away from S. And since I'm moving everything to the right, I know that R has to be located right here. But how do I make that 90-degree angle with my vertex T to prove it? Well, if I make a diagonal from R to T and then make that same diagonal from T to R prime, first of all, they are the same distance. Second of all, they are creating a beautiful right angle up here in the corner. So I know that I'm moving to the right, which is counterclockwise, and I am also moving 90 degrees because I created a 90-degree angle. So now let's take a look at those new coordinates. Remember, for S, I started at 2, 13, and at S prime, I ended at 11, 4. Now for R, I started at 2, 11, and I ended up at 13, 4. Here's the question. Do you see anything or any relationship between these coordinates that I could just apply any rule for? The answer to that is no. There is no rule to rotate figures about any point. So unfortunately, we can't follow a set rule like we can for our other rotations. So you just have to remember that you're creating the type of angle that's given and you're moving in the direction that they tell you. What are the properties that are preserved under rotations? Well, guess what? They never change from the last videos that we've shown you. The distance or the lengths of the segments are still going to be the same. So line segments will still map to line segments. Nothing has changed. Also, our angle measures will remain the same. So angles will still map to angles. Perimeter must stay the same because my distance around the figure remains the same because my line segments are the same. Oh, let me fix that. There we go. My area has to stay the same because if my angles are the same and my line segments remain the same, the area inside the figure stays the same. What about orientation? Remember, that's the direction that my letters are going in. So here, if I move to the right, I'm going A to B, B to C, C to A. Once again, if I'm moving to the right, I'm going A to B prime, B prime to C prime, and C prime to A. So they stay in the same orientation. So these are the properties that are preserved under rotations. We hope that you learned something tonight, and you can bring it with you tomorrow and show us what you know. See you then.